Section 5.3 is about the double angle formulas, the power reducing formulas, and the half angle formulas. Lots of new formulas. I am happy to report that there are no formulas in this section that you need to memorize. There may be some that you choose to memorize. You might accidentally memorize some of the ones that you use more often, okay? But what you're going to be responsible for is being able to derive them as well as to use them, okay? Now, if I say use the double angle formula to evaluate this and you have it memorized, okay, great. But if I say derive the double angle formula, you need to actually derive it, not just state what it is. And we will be deriving all of these formulas as we work through the video lectures. Okay. Basically, the double angle formulas are going to come to us from the sum formulas that we learned last section. And then these other formulas are just basically manipulating and moving around the double angle formulas. Okay, so let's see how that works. Let's suppose I wanted to find sine of 2 theta. We're going to have a formula for that. We're going to call that the double angle formula for sine. Okay. Now, this all comes down to making a brilliant observation. I so love it when I get to point out something ridiculously obvious and feel clever for doing it. But 2 theta is just theta plus theta. So, gee, if I had a formula for evaluating the sine of a sum of 2 angles, I'd be able to use that. And I do. I'm just going to remind you of the sum formula. Oops. The sum formula was sine of u plus v was sine u cosine v plus cosine u sine v. So basically what we're doing here is we're plugging in theta for both u and v. So I'm going to get, instead of sine u, sine theta. And instead of cosine v, cosine theta. Plus, then I'm going to get, instead of cosine u, cosine theta, times, instead of sine v, sine of theta. But if I take a look at that, these are actually the same terms, because sine times cosine is the same as cosine times sine. I know that with multiplication, order doesn't matter, so I can consolidate and just say that's 2 copies of sine theta, cosine theta. Very cool. Okay, not a super difficult formula, one that you might choose to memorize, one that you might accidentally memorize just by using it a bunch as you work through the homework. Okay, but do be aware, if I ask you to derive it from the sum formula, I'm asking you to show me this work. Okay, let's do the same thing for cosine. So if I wanted to evaluate cosine of 2 theta, I'm again going to make the very brilliant observation, and this always makes me feel so clever, that 2 theta is theta plus theta. So I'm really just going to be using the sum formula for cosine. So let me write that out again just to remind us. Cosine of u plus v was cosine u cosine v minus sine u sine v. So again, we're just copying this formula, but replacing both u and v with theta. So cosine u becomes cosine theta. Cosine v becomes cosine theta. Minus sine u becomes sine theta. And sine v becomes sine theta. And of course, cosine times cosine is cosine squared. So that's cosine squared theta minus sine squared theta. Now, it turns out that with the double angle formula for cosine, there are actually 3 different versions that we can use. So let me, just to clear up some space, I'm going to just write the results that we have so far. So sine of 2 theta was 2 sine theta cosine theta. Cosine of 2 theta is cosine squared theta minus sine squared theta. That's the version that falls out directly from just plugging into the sum formula. But you'll notice that on the right-hand side of this formula, I've got some cosine squareds and some sine squareds. I've got a Pythagorean identity that I could use. I know, just off to the side, I'm going to write that cosine squared theta plus sine squared theta is equal to 1. Now that means I could solve for cosine squared, and I could say cosine squared of theta is 1 minus sine squared of theta. So, if I wanted to, I could say this means cosine of 2 theta is, instead of writing cosine squared, I'm going to write 1 minus sine squared theta, and then minus sine squared theta. But that means it's 1 minus 2 copies of sine squared theta. Now, I'm going to just copy that's still equal to cosine of 2 theta, of course. I'm just going to write it again so I can box it. What's nice about this version is it gives me a relationship between just two functions, cosine of 2 theta and sine squared of theta. Granted, an algebraic manipulation of that, okay? But the two trig functions I have are just a single power of cosine, evaluated at 2 theta, and sine squared, but evaluated at theta. This version of the double angle formula, I'm really working with 3 different trig functions. Cosine evaluated at 2 theta, cosine squared evaluated at theta, and sine squared evaluated at theta. Okay. In second semester calculus, you end up using this formula a lot because it turns out that some of the calculus stuff that you want to do, of course, since you haven't learned calculus, I'm just going to have to refer to this as doing calculus stuff. Some of the calculus stuff you want to do to an even power of sine like this, it's much easier to do to the cosines, a single power of cosine. Okay. I said there was a third version of the double angle formula for cosine. That's because I could also have taken my Pythagorean identity and solved it for sine squared. Sine squared of theta is 1 minus cosine squared of theta. Okay. So I could also have said, just starting with cosine of 2 theta is cosine squared theta minus sine squared theta, which is the original version that I got. I can say that's cosine squared theta minus the quantity 1 minus cosine squared theta. Of course, I need to remember to distribute that negative. When I distribute the negative, the 1 becomes negative. This becomes a positive cosine squared. So we get 2 cosine squared theta minus 1. And that's my cosine 2 theta. Okay. So 3 different versions that we have for evaluating cosine of 2 theta. And this one gets used a lot in second semester calculus as well, again, because it has the advantage of relating just 2 different trig functions, whereas this version relates 3 different trig functions. Okay. And we've only got the one version of the double angle formula for sine, but that's okay. That's what we have. Okay. So you're responsible for knowing and being able to use all of these formulas, okay? But as I said, you can sort of decide what you're going to memorize and what you're not going to memorize. Do make sure, though, if you memorize them, that you don't just memorize them, because I might ask you to derive them on an exam or a quiz.